A pleasant viewing to you all. My name is Martin Tatenda Chipiro, known in the social circles as Miss Guardiola, and today I will be teaching you variation. Before we start, I want you to understand that variation is one of the 14 topics we have in mathematics syllabus B. It's actually on number 6, right? You are most likely to see questions on variation in your exam. If you haven't subscribed to our channel yet, I will encourage you to subscribe and turn on the notification bell so that you won't miss the lessons we will be having. This episode is brought to you courtesy of Unlockwise. So let's dive into the lesson. Right. So by definition, variation is the description of relationship between variables connected by a constant known as a constant of variation or a constant of proportionality. Right. So we are going to look at 4 types of variation. We have what is known as direct variation. We have what is known as inverse variation. We have what is known as joint variation, and we also have partial variation. So I will start by teaching direct variation. So let's dive into the business of the day. We have what is known as direct variation. Right. So what I want you to know is we can have this as statements, and we'll take the statement and write it in variation form, and then express it as a statement, an expression, an equation connecting the variables and a constant. And then we can be asked to find the value of the constant, and then find the value of one variable given the constant and another variable, the value of the other variable. Right. For example, let's say we have a statement y varies directly as x. Right. Now, having this statement, y varies directly as x, you can write this in variation form. You can write this in variation form, y varies directly with x. Right. Now, what this means, I want you to understand this. This side is a variation sign, or we can call it a proportional sign. And for us to change this statement into an expression, into an equation, we will remove the proportion sign and put an equal sign, and also introduce a constant. What am I saying? We will have to do this. You write y is equals to kx. This is how we remove the proportion sign, the variation sign, and introduce an equal sign and a constant of proportionality. Now, after you have done this, you can be asked to find the value of k, right? Let me do this. You can be asked to write y is equals to 10 when x is equals to 2. So we want you to find the value of the constant k. right? So if you can check from what we have this as y is equals to kx, and we are going to substitute the value of y and the value of x. What is our y? Our y is equals to 10. And what is our x? Our x is equals to 2. So if you can simplify this, you have 10 is equals to 2k, and then we can divide both sides by 2 and find the value of k. Now k is equals to 5, right? So this is how we find the value of k. All right. So I also want you to understand this. You can also be asked to find the value of one of the variables after you have managed to calculate the value of k, right? I will do this with an example. So given that m varies directly to n squared and m is equals to 28 when n is equals to 2. Write down an expression for m in terms of n and a constant k. Then we also want you to calculate the value of k. This is part B. And we also want you to find n when m is equals to 63. So let me do this so that I can put my workings there. Right. So the first thing I want you to notice, is that you are given that m varies directly to n squared. Right. One of the things I have noticed and I have learned to appreciate on variation questions is the first statement will tell you the type of variation you are dealing with. The first statement will tell you the type of variation you are dealing with. And then you can also be given this as it varies, it is directly proportional. It's one and the same thing, right? Directly proportional or directly varies is one and the same thing. So I'm saying the first statement will tell you the type of variation. So in this case, we are dealing with direct variation, right? So this varies directly to n squared, right? So we are going to write our statement in variation format. M varies directly to n squared. Right. Having wrote this, I am going to change this into variation, into an expression, into an equation, because I am asked to write an expression for m in terms of n and a constant k. So what I'm going to do is I'm going to write my m and remove the proportional sign and introduce an equal sign k, which is the constant of proportionality, and have n squared. So this is now my expression. M is equals to k n squared. So let's move on to the next question, which is actually asking me to calculate the value of k. Right? We have been given some values here. M is equals to 28 when n is equals to 2. So we are going to substitute. Right. So our equation is m is equals to k n squared. But we are told that m is equals to 28 when n is equals to 2. So we can have this as 2 here. Oh, let me write it properly. We can have this as 2 squared. So this is going to give us 28, which is equals to k, and this is going to give us 4, and I prefer writing it as 4k, so that I can have the number as the coefficient. Divide both sides by 4, and then I will have 7. So k is equals to 7, right? So this is my answer for part B. Then I am now requested to find the value of n when m is 63, right? So we want to find the value of n when m is equals to 53, right? So allow me to maybe put myself in here and put my equation here, because I want to rub where I am working, so that I can continue. Okay, right. So our equation states that m is equals to k n squared. And we now know that our value of k is 7. So we are going to replace it here. Right. And I mentioned this before, that you will be given one variable and be asked to find the value of the other variable. So in this case, we are given m is 63. So we are going to say 63 is equals to 7 and squared, right? After this, we are going to divide both sides by 7, and we will have n squared being equals to 9. For us to find the value of n, I'm going to put a square root on the side and then cancel the square on the other side. This means that we are going to have plus or minus 3 is our answer. So n is equals plus or minus 3. This is right. So we are moving on to the next type of variation. This was direct variation. But one thing I also want to say before I move on is that for direct variation, as one quantity increases, the other also increases. Just like we can have the bread and the price of the bread being $1. So if we increase the number of loaves we want, the price will also increase. If we decrease the number of loaves we want, even the price will decrease. That's direct variation. Then we move on to the next type of variation, which is inverse variation. Inverse variation. Inverse variation. Now, for inverse variation, as one quantity increases, the other one will be decreasing, right? Let me give you a very understandable example. Let's say I have a birthday. I have a birthday party. I'm hosting a birthday party, and I have my cake, right? If I am going to eat the cake alone, I'm going to eat the whole cake. I am going to have everything for myself. But maybe if I invite friends and family, the more we have other people coming, then the smaller becomes my share, right? From being a whole cake to maybe a half, a quarter, an eighth, or so on. Because as the number of people who are coming increases, the share of my cake will be decreasing, right? Okay, so I also want you to notice this. When we are dealing with inverse, we are going to have it to the power -1, or it will be written as 1 over whatever variable we have, right? For example, I will give you an example. So let's say given that f varies inversely, as w a write down an expression you have to write down an expression for f in terms of w and a constant k, and the part B follow-up question, given also that f is equals to 15 when x is equal to 35, calculate one the value of the constant k, and you are also required to calculate w when f is equals to 10,5. So this is our question, and let's answer it. Like what I have highlighted before, the first statement will tell you the type of variation you are working with, right? If you to check here, given that f varies inversely, which now means that we have inverse variation. So we are going to write down an expression for f in terms of w and a constant k. Right. So what are we going to do? We are going to have f varies 1 over w, like this. This is the statement in variation form, right? But we are asked to write an expression in terms of w and a constant k. So what we are going to do is we are going to introduce a constant k. When we remove the variation sign, we will introduce equal sign, and k, which is the constant of proportionality, and we are multiplying this with 1 over w, and this will give you f, which is equal to kw. Right. Allow me to explain this a little bit, in case some might actually be wondering. We have f being equals to k times 1 over w. So what are we going to do? We are going to say over 1 here, and then numerator times numerator, k times 1, which will give you k, and 1 times w, which will give you w. That is even why I had to write it as k over w, like that. Let's hope it's clear. And let me move forward. Right. Then we are at a point that we are supposed to calculate the value of k, because given also that f is equal to 15, when x is equal to 35, calculate the value of the constant k. Right. So we take our formula. F is equals to k over w, and then we substitute the values. F is equals to 15 when it's actually when w, it's w here. So f is equals to 15 when w is equals to 35. So we are going to have k over 35 here. Right. So for us to get the value of k, we are going to multiply both sides by 35. So we have 15 times 35 on the side, which is equals to k. Right. What is 15 times 35? 15 times 35 will give you 525, which is the value of k. So k is equals to 525. Let's just verify if that is it. 15 times 35, it will give us 525. So that's correct. It's okay. Then we also have to calculate the value of w when f is equals to 10.5, right? We have to calculate the value of w when f is equals to 10.5. So let me just write my formula somewhere so that I have f is equals to k over w, and then my k is 525. It's okay, right? Right. So if we have f being equals to k over w, and our k being equals to 525 over w, and we are asked to find w when f is equals to 10.5, you substitute 10,5 here, which is equals to 525 over W. Right. So what we are going to do is we are going to multiply both sides by W, and we have 10,5 W, which is equals to 525, and divide both sides by 10,5. 10,5 divided by 10,5, and this will give us W, which is equals to, what is 525 divided by 10,5? You should be able to get something like 50. So this is your answer. 10,525 divided by 10.5. This is 50. That's awesome. Right. So I will give you another example. On inverse variation. Right. Inverse variation. So let me call this example 2. Right. It is given that y varies inversely with x minus 3 and that y is equals to 4 when x is equals to 2. Express y in terms of x. So what I want you to notice here is already we have been told the type of variation, right? And we are supposed to write this in variation form, right? Y varies inversely 1 over x minus 3, right? And then given that y is equals to 4 when x is equals to 2, express y in terms of x. So what I want you to see is we are going to change this into an expression. Y is equals to, let me just write k over x minus 3. And I think I have explained why I will have k on the numerator, because you are going to say y is equals to k multiplied by 1 over x minus 3, and then you multiply numerator and numerator, denominator by denominator, then you get k over x minus 3. So what you do now is you substitute the value of y, which is 4, is equals to k over, what is my x? 2 minus 3. So this is going to give me 4, which is equals to k over 2 minus 3 is minus 1. And then if you multiply both sides by minus 1, you are going to get minus 4, which is equals to k. So my k is equals to minus 4. But the question now doesn't even ask me anything about k. It asked me to express y in terms of x. Now, this means that we are not supposed to write the k on the equation, but rather replace the k with the value of k, so that our expression will be of y in terms of x. So I want you to notice this. I will have my k here, my k, which is equals to -4. So the expression now, the expression should now be y is equals to -4 over x minus 3. This is the expression of y in terms of x. Okay, so let's move on to my last example on inverse variation. Which is example number 3. Given that y is inversely proportional to x minus 1 squared and y is equals to 2 when x is equals to 7. A express y in terms x plus 1, and then you are also required to calculate the values of x when y is equals to 8. Right. So what I want you to notice here is given that y is inversely proportional, I think I've mentioned this before, that the issue of proportionality and variation being the same thing, and you are told the type of variation in the first statement, right? And then now this is y is inversely proportional to 1 over x minus 1 squared, right? And we can remove the constant, the variation sign, and introduce a constant of proportionality and have it like this. So express y in terms of x. But I have highlighted that when we are told to express y in terms of x and there is no constant, we have to calculate the value of k and then replace the k with the value, so that we have our expression in terms of y and x. So what we are going to do here is we are going to say y is equals to 2 and k over, what is our x? Our x is 7, so we are going to write 7 here. 7 minus 1, and this is squared. So we will have this as 2 is equals to k over, what is 7 minus 1? 6, and the 6 is being squared. So we have 2 is equals to k over 36. And now, if we multiply both sides by 36, we are going to have 2 multiplied by 36, which is equals to our value of k. So k is 72. Our k is equals to 72. Right. So if k is equal to 72, we want now to replace there. And we can have this as y is equals to 72 over x minus 1, which is squared. So this is our expression, our y expression in terms of x. And now we want to calculate the values of x when y is equals to 8. So let me just put this here and then we'll work with it. Right. Okay. So y is equals to 72 over x minus 1 squared. And we want to calculate the values actually. Values. Take note of this word. Values means we are going to have two values. Right. So our y is 8 and then this is 72 over x minus 1 squared. So if we multiply both sides by this term, we are going to have 8 bracket x minus 1 squared, which is equals to 72. And if we divide both sides by 8, we are going to have x minus 1 squared being equals to what is 72 divided by 8 is 9. So we are going to take off the square part here and put a square root there. So we are going to be left with x minus 1, which is equals to plus or minus 3. So our x is going to be 1 plus or minus 3, which will give us x is equals to 4 or minus 2. This is our answer. X is equals to 4 or minus 2. Right. So we are done with inverse variation. I want to take you to joint variation. We are going to look at joint variation. Now, joint variation can be a combination of direct variation, indirect variation, that's one. Direct variation and inverse variation, that's two. Or we can have inverse variation and inverse variation. I even think that the joining part actually is consistent with the name because it's joined. We are joining some variation. So let me dive into an example. If V varies jointly as H and as the square of R, A write down the equation connecting V, R, H and a constant C. Then the B part, find C if V is equals to 440, R is equals to 2, and H is equals to 35. Right. So allow me to do this. We will write this in variation format. V varies jointly. So the first statement will tell you the type of variation, and we will have V which varies directly, which varies jointly as H, and the square. Take note of this word. It's the square of R, right? And we are asked to write down the equation connecting V, H, R, and a constant C. So we are even given the letter to use as constant. So we are going to say V, replace variation sign with equal sign, and put our constant of proportionality, which is C, and then H R squared, right? So this is going to be our equation connecting V, R, H, and a constant C, right? Then the second part asks us to find C if V is equals to 440, R is equals to 2, and H is equals to 35. So V is equals to C H R squared, and what is the value of V? 440, and we have C. We want the value of H, which is 35, and we also have R being 2, and it's squared, by the way. So if we multiply the others, we are going to have 440 here, and we are going to have something like 100, and what is 4 times 35? It's going to be 140. So we are going to have 140 here, and we have C here. So we are going to divide both sides by 140. And this should give you something like 3 and 1 over 7. Right, maybe let me take you halfway. You can say 10, right? Divide both sides, divide the numerator and the denominator by 10, and maybe divide this by 2, you get 22, and divide this by 2, you get 7, and then 7 into 22, you get 3 and 1 over 7. So that's one part. Let me do one more example, and then we can move on to our last type of variation, which is partial variation. Right. So you're going to have another example here. It is given that X varies directly as Y, and inversely as the square of Z. right? Then x is equals to 15 when y is equals to 27 and z is equals to 2. Right. So we want to find the value of z when x is equals to 30 and y is equals to 294, right? So what I want you to understand here is we are going to have x varying directly as y. So we are going to have x varying directly as y and inversely as the square of z, right? So allow me to just say 1 over z squared, like this. So if we combine this, we will have x, which is varying y over z squared, right? And we want to remove the proportion sign and replace it with the equal sign. So we are going to have this as x is equals to k y over z squared, right? So this is what we have now. And we are going to substitute x here is 15 and k, what is our y? Our y is 27 and our z is equals to 2. So we are going to have 2 squared, right? We are going to have 2 squared here. So maybe 2 squared will give us 4. So if we want to calculate the value of k, we are going to have 15 multiplied by 4, which is just 2 squared, and here we will have k multiplied by 27. All right, so I will divide both sides by 27. Divide by 27. Divide by 27. So this will cancel each other, and my answer will be something like my answer will be something like 60 over 27, which is the value of k. And we can even reduce this. If I divide this by maybe 3, I will get 3 into this one, 20 over 3 into this one is 9, right? So k is equals to 20 over 9. Now, having found this, allow me to write this as x, which is equals to 20 y over 9z squared. Why have I decided to write this like this? Okay, let me just explain a bit, and then you understand what I'm doing. Right. Initially we had x being equal to k y over z squared, right? And our value of k is 20 over 9. So we can write this as x being equals to 20 over 9 times y, and this is being divided by z squared. So if you multiply numerator by numerator, denominator by denominator, you are going to have 20 y over 9 being divided by z squared. And for us to divide this, we will multiply by the reciprocal of this one, which means that we are going to have z over 1 here, and it will become 1 over z squared, right? So it's 20 y over 9 times 1 over z squared. And if we say numerator times numerator, we are going to have 20y. And if we say denominator times denominator, we are going to have 9z squared. That is even why I had to write it like this, right? So let's hope you understood why I had it like that, right? So it's okay. Having done that, we want to calculate or find the value of z when we want to find the value of z when x is equals to 30 and y is equals to 294, right? So we are going to use this formula. Okay, x is equals to 20y over 9z squared. What is the value of x? Is 30 and 20 here. What is the value of y? Is 294 then divided by 9 z squared, right? So what I want to do here is I want to maybe multiply both sides by z squared. I will multiply both sides by z squared. Let me do this so that you understand it. Z squared here and multiply by z squared here. So what is going to happen is this one is going to cross out this one, and we will remain with z squared. Okay, let me just have it as 30z squared, which is equals to if you multiply 20 by 294, you are supposed to get 5,880, and this is being divided by 9, right? So having done this, we can maybe also divide this by 30 so that we will have something like so I'll be left with z squared, which is equals to, or maybe let me divide this one 5880 divided by 9, you will get, oh shit, okay, anyway, let me put it this way. If we have if we have 5880 being divided by 9 and then being divided by 30, it means that we have something like 5880 80 divided by 9, and we divide like this, and 30. Change division sign into multiplication sign, and then you invert. So we are going to have 1 over 30 like this, which is multiplying this, right? And then numerator times numerator, denominator times denominator. So I'm going to be left with z squared being equals to 5880 divided by 9 times 30. Okay, we have this now. That's my wife. Okay, so this should give me 0 to 7, right? And this is now 5880, right? So I think this is manageable, right? 5880 divided by 270, you get something like 21,777. This is recurring, by the way. So from there now, we are going to have this z. We have our z squared being equals to 21,777, whatever. And if we do this so that we can find the value of z, we are going to get z being equals to 4,7, right? So yeah, should be it. The square root of all right, you can use your calculator and get the square root of 21,777, and it's somewhere here 4,7, right? So we want to move on to the last type of variation, which is partial variation. Now, so this one is partial variation. What happens to partial variation is it does have two constants. Partial variation has two constants, and you should be able to solve simultaneous equations so that you be able to calculate the values of the constants, and then you can answer the question with ease, right? For example, we have x is partly constant and partly varies is y. Then now we want to express x in terms of we want to express x in terms of y and constants h and k. Then there is also a follow-up question. Given that x is equals to 1 when y is equals to 8, and that x is equals to 3 when y is equals to 12. Calculate the value of a1 h2 k, and I also want you to find the value of x when y is equals to 30. Right. So maybe if I give you an example, a real life example, you will understand what partial variation and how partial variation works. We have private candidates who register to write their exams at schools, right? We have center fee being constant. Center fee will not change because of the numbers of subjects you are writing. Center fee will remain constant. Then the price for the exams, right? Exam fee these days is $24, and now the number of subjects you are writing will determine the amount you are going to pay for your exams, but you are also going to pay for the center fee. So the center fee is constant, and the price, the money for the exams, right, is partly varies due to the number of subjects you are writing. Okay. Anyway, back to our question. X is partly constant. This one is partly constant, and it partly varies as y. So what we are going to do here is we are going to write x being equals to h plus k y, right? Because we are asked to express x in terms of y and constants h and k, right? So this is y is equals to h plus ky. X is equals to h plus ky, right? This is our expression. So let me call this A. This is our expression in terms of y, right, and the constant h and k, right? So given that x is equals to 1 when y is equals to 8, and x is equals to 3 when y is equals to 12, right? So we want to do this. This is part. X is equals to h plus ky, and we are told that when x is 1, y is equals to 8, and when x is equals to 3, y is equals to 12, right? So we want to calculate the value of h and the value of k. So what will happen here is we are going to have 1 is equals to h plus 8k. I will call this equation 1, and then 3 is equals to h plus 12k. I will call this equation 2, right? And we are to solve the simultaneous equation and get the value of h and the value of k. Okay, so I want you to set this. I will rewrite this. I will start with the bottom one and maybe say h plus 12k is equals to 3 and have h plus 8k is equals to 1. Right. I am going to use a method of elimination, and if you can see, we have h here, we have h here, and the coefficients are 1, so the coefficient is the same, and I can eliminate h. If you have same letter here and have the same coefficient, which is even both positive in this case, you can simply subtract, right? So I will subtract here, subtract h minus h, this will cancel each other, so I will remain with 12 minus 8, which will give me 4k, and then this is equals to 3 minus 1, which will give me 2, and then if I divide both sides by 4, k is equals to half, right? And I also want to calculate the value of h, so let me use this one. So one is equals to h plus 8. The value of k is half, so I'm just gonna get h here. It will be half of 8, which is 4. So 1 minus 4 is equals to h. So my h is going to be minus 3, right? That's the value of h. So k is equals to half, and h is equals to minus 3. I want those values, so let me just put them here. Right. So back to our initial equation. We are going to see that we will now have x is equals to h plus k y, of which our value of h is minus 3 plus our value of k is half y. So this is now our equation, right? We now have this as our equation. So what we are now supposed to do is we want to find the value of x when y is equals to 30, right? So we will find x is equals to minus 3 plus half, make this big, plus half of y, which is 30. And this means that we are going to have x is equals to minus 3 plus, what is half of 30? It's 15. So we are going to have 15 here. So x is equals to minus 3 plus 15 is 12. So this is the value of x. Right. So I think we have managed to cover the 4 types of variation, and I have provided sufficient examples to get you started. You can now visit your past exam papers and see if you have managed to understand the topic variation. Is a topic done in a day? We have covered the whole topic in matter of hours, matter of minutes rather, right? So I want you to understand this in conclusion. You will be told the type of variation by the first statement, right? The first statement will tell you the type of variation. Then you will be expected to write the expression connecting your variables and a constant of proportionality or a constant of variation, and then you will be expected to calculate the value of the constant, and you will be asked to maybe give the value of one constant, the value of one variable given the other. So from me, Ms. Guardiola and Unlockwise team, till next time is bye for now.